All right, welcome back to the ReWork Podcast, first ever episode in English. So maybe we'll put some subtitles below, not sure yet, we'll see. But our guest today, one of the more famous people in the online sports science fitness space, we have today with us Gommaar. Give us a short elevator pitch, a short hello about yourself, what you're doing, what you're all about.
Hi everyone, I'm Gommaar D'Hulst. I'm a sports scientist by craft. I studied sports sciences back in the day, also did a PhD in sports sciences and high altitude physiology. Then I went to Switzerland to still pursue my PhD and my postdoc. But while I was doing all these interesting, let's say, applied experiments for mostly related to sports science, I was thinking, actually, not many people do read my papers, right? Or the things that I put out here. Maybe my peers do it, but not that many, let's say, coaches and athletes. And that's why I started What Science together with Henning Langer, German colleague. And yeah, this grew organically and we're trying to, let's say, disseminate papers towards the grand public and new information in the, let's say, the high-intensity functional sports, such as CrossFit, HYROX, and everything related to that, because I think it's very interesting from an exercise physiology point of view. And that's also 50% of what I'm doing nowadays, and 50% I'm still working for the university, lecturing mostly exercise physiology. So really entrenched in all these sciencey, geeky things, but I think quite interesting.
Yeah. Well suited, like this, you're at the very intersection between applied and theoretical, and it must sometimes pull you apart quite harshly, and sometimes maybe it's just the greatest thing on earth. You're from Belgium originally?
Yeah, correct.
What was it? Yeah, okay. So there's a huge like cycling scene in Belgium, obviously. Have you ever gotten in touch with the endurance side of things? I mean, you're in like these functional sports, power. High intensity endurance. Have you ever gotten in touch with cycling at all?
Yeah, absolutely. Because at the laboratory where I did my PhD was in Leuven, so in the middle of Belgium, the biggest university in Belgium, together with Ghent. We had a professor, Peter Hespel. He's kind of my hero in the whole thing. And he was the advisor of Omega Pharma Quickstep, so Quickstep team, with Tom Bonen and all the heroes
all
from
these
then.
classic guys.
guys.
The one day.
And and they came in for their exercise test to exhaustion there in our lab, in our basement.
Oh wow! Did you test those guys or what?
Yeah. So I tested them and I was there. And cool. they were putting enormous wattages, like insane.
Can you give us some numbers? Actually, I mean, that's quite some years ago. So maybe
this is from some years ago. Obviously, back when the animals could still talk. But this was. Yeah, so we did crazy tests. We did 8-minute tests. So we took lactate after 4 minutes and after 8 minutes within the same block. Right? Okay. To really have the steady state in lactate. And these guys were ending their tests at 450 watts. So ending, so they could push.
Wait, 8-minute tests or 8-minute stages in a
stages?
Step test? Or? Okay,
stages.
Wow.
So we're talking about 1 hour 15
wow.
tests.
Oh,
this is enormous. They had a. Yeah, like also Tadej Pogačar, he has like a zone 2 of 330 watts, right? Like, which is insane. So this is the caliber that was sometimes passing along in our laboratory. Okay. So pretty cool.
What kind of lactate values did these guys have?
No, not so high, not so specific. Most of the time they just stopped at their threshold because they didn't want to kill themselves the last 8 minutes.
Right.
And so the
tests were long enough as they were.
Yes.
Right. I mean,
yes. So and we also had and that's also where I did my PhD. We had a hypoxia room. So it was a room. Obviously, Belgium is very low and flat. So the people came in there. It was also a hotel to train in high altitude. So we could put that room up to 5,000 meters. Also did some experiments there related to muscle loss. So that was kind of the laboratory where we worked in, where I started the whole thing about sports science.
Super cool. Why didn't you stay in endurance sports then? I mean, if I know some people who get to work in labs and then they get in touch with whatever sport is around, like whatever kind of pro athletes are living nearby, and then usually they stay there. But you pivoted like way hard into these functional, power-driven, high-intensity sports. So
yeah, kind of. I mean, I was always kind of. I'm saying that I did exercise physiology, yes, but also molecular biology. So we took muscle biopsies and I analyzed the enzymes in the laboratory, did mouse experiments, cell experiments. So really deep dive into what happens if you provide nutrients mostly to skeletal muscle. That was my idea. And how does a muscle grow or how does it lose, let's say, mass, right? And this was part of my whole idea together with some of the endurance things that I just talked about. And then I just went to I followed the opportunity. There was a new laboratory that was opened by my professor now, Katrien de Bock, the Laboratory of Exercise and Health, and this was in Zurich. And then I just followed her there. And was able to do like more molecular biology into sports. So really sciencey stuff.
Is this something you wanted to do all along, like mechanistic research? That's what drove me into sports science was like I became a triathlete when I was 12, 13 years old. And then, as many people think nowadays, hey, how can I maybe train myself a little bit? What am I actually doing? But then I started to get my hands on these mechanistic papers like molecular biology, these pathways, upregulation, downregulation. And I got so soaked in. But then I got a bit, how do you say, like delusioned, like like mechanism versus real life. Yeah. That's a big topic, fully obviously. Agree. So first of all, what made these mechanistic researchers, molecular biology, so interesting to you? And how do you see it nowadays versus applied in vivo real life?
Yeah, it's an excellent question, obviously. So back in the day, I mean, I was really a newbie, and I just want to know more how it actually worked. So as I said, I was not really into pure endurance sports. I mean, it was part of my education, but my, let's say, my PhD was rather in what does hypoxia, so low oxygen environment, with muscle mass. So how is it possible that if you go to the Mount Everest for 2 months, you come back with 15% less muscle? Right? How come that certain diseases lead to loss of muscle mass that also are related to low oxygen environment? So that was really mechanistic. So this was just obvious for me that I had to do mouse experiments, cell experiments, and so on. And applied side just came a bit later when I just started doing CrossFit myself. So I was really in the academic world, certainly also even the applied stuff in sports sciences. It was very PT and strength and conditioning. You have to do strength and then maybe endurance if you want to specialize in those. But then some dude called Greg Glassman came into the world and said, you have to combine it. You have to do high intensity. You have to do gymnastics, running. And I was quite intrigued by this also because it was a little bit not mainstream and I really like to train like that. There was also a lot of weightlifting and strength involved in this, which I liked. So that was just the applied side. And then with my exercise physiology background, I was thinking, okay, this is interesting. Like those guys train like that. They become really unbelievable athletes. How is this possible? Right. How come they can row quite decent and also snatch 300 pounds? And this was my scientific interest purely because of the practical side. How is this possible? And I think still to the day, there's not many researchers who are looking into this. They're still very conventional, looking at, what happens to, for example, Tom Bohne if I train him, pure endurance, right? Like that's interesting. What happens to a weightlifter? But what if you combine them, the interference effect? This was really something that still to this day intrigued me a lot.
Yeah, so much to discover. I mean, we've discovered so much. We have such advanced technologies, like ways of doing research, and still so many questions unanswered. Let me run by you a quick theory of mine. I've never heard it quite put like this, and I think you're just the person to say, "Hey, you're onto something, Massimo," or "I don't know so much." I'm thinking of the scientific process, like in our field, sports science, for example. I think of 3 big domains. Yeah, like one domain for me is mechanism. Then one is epidemiology, like what do we see in broad data sets? And then one is RCTs, like experiments, controlled experiments. And I feel like there's knowledge out there, there's research pertaining to mechanisms. And then sometimes this gets blown up. There's a mechanism, and because this is on the cellular or molecular level, this must apply because this is the basis for everything. Yeah. And then obviously epidemiology, and we know correlation doesn't equal causation, blah, 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 and experiments. And all of these 3 domains have their pros and cons. But I think there's very, very, very little where we have converging evidence in 2 or maybe all 3 of these domains. So what do I mean specifically? There's mechanistic research out there. For example, the interference effect, right? That's a wonderful example. We know the AMPK, pathway versus mTOR, and there is this interference thing on the molecular level, and therefore endurance and strength don't go along. And then there come experiments, there comes more epidemiological data, and we see, it's maybe not as clear cut. So, okay, my actual question to you is, sometimes mechanism can mislead us. And there's actually very, very little knowledge out there where all 3 domains converge. Like, you know what I mean? You know what I'm getting at?
You're completely onto something. I mean, this is one of the problems in science, to be honest. One of my frustrations. If you talk about AMPK and mTOR, right? Like the idea that this was indeed mechanistically kind of interfering was based on pure mouse studies. So what they, for example, did, they injected ICAR, which is a stimulant of AMPK, into mouse, arresting mouse sitting in a cage, which is already a big problem because most of the mice that run around in wild nature are obviously not sitting. And then AMPK goes up, and then they also stimulate protein synthesis in mTOR, and then you see that this is reduced when AMPK is higher. This is like very mechanistic in mice in a sedentary mouse, right? Like you just increase AMPK with pharmacological agents and then also mTOR. But then actually, there were actually, related to interference, there is some good science, I would say, even mechanistically. They did the same in humans, where they increased via endurance training AMPK, like sprint training and mostly endurance training. And then they also provided mTOR and an increase in mTOR with resistance training. And then they did not see this blockage of AMPK on mTOR. They did not see this, right? And this was in human muscle, to your point, more in a physiological, typical way how you do strength as well as endurance. So this was also ringing to me like a bell to me, like maybe this interference thing, it could potentially be there, but maybe it's more a matter of training volume than actual biochemical interference. Meaning that a CrossFitter is a good example, can never do as much weightlifting volume as a pro weightlifter or a cyclist. Right. I think this is 90% of the explanation, maybe 80%. So indeed there is to your point not that much because I mean to answer your question, it's just not that easy to do. You need specialized laboratories that need access to medical doctors that can take biopsies, right? Because you kind of need biopsies in some way or another. And with the human study, first, it costs a lot of money, which is a problem. And second, you have one shot. You have one protocol. This is it. Like if I do something wrong in the protocol, like I put my endurance type of training too early, or I wait too long with the muscle biopsy, it's not going to happen. The signaling is gone and so on. So it's really tough. And with mice and cells, it's obviously much more easy. You see this also in my laboratory. If something doesn't really work, we just take a new batch of mice or cells. And then obviously the total data set mechanistically will be much higher coming from mice. And to many people's, let's say, frustration that are not really into research, they say, most of this is on mice. It doesn't really represent the human. In some way, certainly with sports science, I think they have a valid point, to be honest. Right? Certainly sports science, I'm talking about. Other
normally
sciences.
People don't quite go that far, or rather there's such huge, what do you call it? Like psychological diversion, like when people think one thing and the opposite at the same time. What do you call it? You know what I mean? Like on the one hand, people sometimes say, hey, there's this study, and this study says A. Period. Like no questions asked. What's the methodology? What's the study? Is it on mice? Is it on humans? What's actually going on? Just here's the results. Let's run with it. And then there's the opposite kind of people who say, like, it's all bullshit. I agree. And obviously both are true, right? Both are true. Like, here's some evidence. Here's a pattern we're observing. Let's take this pattern with, together with all the other evidence, and then we can maybe navigate our way through all these pieces of data. But at the same time, limitations all around. And it's just really complex, right? It's never clear cut. It's complex, and you need to see the big picture, and people are just not really good at this anymore, right? We want
Yeah.
clear-cut answers. We want the definite thing. Yeah.
I mean, it's because there's just low attention span, and these things take time to progress, to learn. You need more than a TikTok video or a reel. You need maybe a YouTube video. You need someone who explains it deeply, an expert. This is just not really how it is anymore, unfortunately, right? In sometimes it is, but by the way, that's also why I started the YouTube channel, not just to avoid these reels, because it's just very difficult to explain certain, exactly what you say, mechanistic studies, observational studies in depth by just doing it in 3 minutes. And even 3 minutes is too long. Like I see it in myself. If I make a reel that is 3 minutes, no one watches it. If it's 40 seconds, it's probably usually good.
Crazy, right? Crazy. And
crazy.
by the way, hats off to your YouTube channel, What Science. Like amazing content, super applied, but also in depth. But even if you create a half hour, or you don't have an hour video out there, right? Maybe I'm wrong, but even if you do have an hour in-depth dive on something, obviously there's so much you have to leave out, because at every single subtopic you could go into a university lecture, and then people just will get frustrated nowadays, because if people get this feeling, hey, it's not as clear cut as I thought, that's almost like psychological pain, right? It causes psychological pain in people if they realize, hey, it's not as clear as I thought.
Maybe one thing that is really confounding, and also to what you just said, I think, is that there is too much observational research. To be honest, maybe some people who listen to this won't like it, but it still is very easy to confound observational research, right? Like, it could be in some way that observational research could be useful, for example, to see if there is a pattern or something, but never try to make any conclusions out of this. And this is what, for example, the mainstream media or what other people just do, understandably in some ways, that they say, okay, this is observation, this is what we found, and okay, that's it. But you need intervention studies. I always say this, you need intervention studies, certainly in applied sports science and even mechanistic sports science. You need mechanistic studies, but keep the observational studies, I don't know, maybe for whatever diseases or something, but try to...
Or theory creation, hypothesis generation, right?
Yeah,
you do these observational epidemiological stuff, and then just like you mentioned, okay, there is something, let's go in with a couple of experiments. And not just one, hopefully, but maybe 100 of those. Can you think off the top of your head of any insights we've gathered in the last few decades where mechanism, observation, and experiment really converge on a central theme? Can you think of? Because off the top of my head, I cannot think of many. So
I did a part of my PhD in Copenhagen, and Copenhagen, those guys are pretty crazy because they can do enormous amounts of muscle biopsies and like blood sampling in humans. So they're one of the few laboratories in the world, first, who can just do it in humans, and second, that are allowed by the ethical commissions. So that's important. And so they have done a lot of work on glycogen, on like training in a fasted state, training without glycogen, and so on. And there is good mechanistic research, in my opinion, also applied on, and also I was involved in some of those studies where they did, let's say 10 years ago, they did a lot of fasted training. So, for example, you had a group of students who came into the laboratory at 7 a.m. They did fasted training for 30 minutes on the bike or something, and another group did the same, but with a breakfast. And overall, they ate the same amount of carbohydrates during the day, right? So it's kind of intermittent fasting, but with the same amount of carbohydrates. That's important. And then, for example, they saw actually not really something happening. They saw more fat oxidation, so they were able to burn more fat. But that's basically it. They did not improve their time trial on the bike or anything performance related. So it's a bit of a bummer always when that happens. But then some researchers for example, in Australia, John Hawley, went a bit further because he's also involved in really training elite athletes. And what he did was a sleep low protocol. So what is that? He went actually a step further where, for example, he did on 6 p.m. in the evening. Let's say now we're recording this at 6 p.m. he did a high intensity training. So interval style training on the bike 5 times 4 minutes or something to really deplete glycogen. Then they went to bed. The athletes went to bed without any carbohydrates. They had a protein shake. And then the next day they did zone 2 training for 90 minutes to 120 minutes without a breakfast. So really low glycogen training. And then they saw actually in running time, they saw an improvement in running time, at 10K running time compared to the same protocol, but with different, with always eating during and before the training. So that's
with accompanying and also did they also measure like what was it like the PSYCHE1 alpha is like this master endurance pathway, right? Did they also measure that? Like they also saw
this is
an upregulation in this, or
so these things they measured in the initial studies of fasted training, and that was always upregulated. So that's what they thought. You increase your mitochondrial content, you increase your signaling towards your mitochondria.
But in those they didn't see the performance.
Yes, they didn't see the performance.
You mentioned,
But then when you really push the system to the extreme, by the way, I did this protocol for 5 weeks. It's obviously very brutal because you cannot sleep after a while. You get used to it, so it's not that recommended. But it does seem that there is obviously some interaction between nutrition and exercise, and if you time it well, you can marginally improve, right? So there are some good studies, and I think it's. I would have to say less and less, but there are some I would say examples, but not really in functional fitness world, CrossFit HYROX. I mean, there we are lagging way behind and only having some kind of observational studies, in my opinion. But
it's also way newer as compared to space. Gold all endurance. I mean, endurance has been around for forever, right? I mean, that's we are, one of the most enduring species on this planet.
Yes.
Do you think pro athletes? I mean, I think not, but is this also your observation? Pro athletes don't usually run with any old new study, new finding, new hypothesis. They have their ways of doing stuff, and it's usually more the age group or the amateur athlete that takes this study finding and just this is the new way of doing it for the next year or so.
Yeah, it could be. I don't know exactly about this. I do know that, for example, cycling is really on top of things. It started all with Team Sky, I think around 10 years ago, where they talked about marginal gains to get always 1% better using ketones. For example, we had a lot of research in our laboratory with ketones. Quite interesting, obviously, as a third fuel source, right? Fats.
Okay, yeah. Let's talk about that later on, because there are mixed feelings about ketones.
Yeah, for sure, mixed feelings. But there was some research, and it all started kind of in the UK. So, for example, the teams, I think the cycling teams, also because of the war on PEDs, right? Like 15 years ago, I think it's certainly less than it was in cycling. So they had to go the more conventional way. And there is some good. There's some money in cycling, which helps for research, obviously, and there's some good researchers that are related to teams, to big cycling teams like Jumbo-Visma. So there is, I think, sports science is pretty high and well equipped in cycling. So I do think that the pros, obviously they don't know, they just follow what they have to do. I don't think they're on top of the research papers, but they have good advisors. Let's keep it like that.
Okay,
for sure.
Cool. Yeah. Okay, cool. Man, so many topics. My head's exploding right now. Let's go back really quickly to what you mentioned earlier when we're talking about the interference effect.
Yeah.
And I loved what you said, because I've had a feeling that this might be the case, and you just mentioned it straight out. You said it might be more of a volume question than an actual mechanistic interference thing. Like in terms of like really down to earth and practical, you only have so much training volume you can put into a week or a day.
Yeah.
And if you focus on one thing versus the other, those are the gains that materialize more than the others.
Yeah.
Like if you pursue both endurance and strength, like obviously you won't get as strong as the person who only does the strength training. And I love this. So first of all, is this actually what you said? Not that I'm misrepresenting you. And then second of all, you think this also applies to other things? Probably they do. Like for example, VO2 max versus marathon performance. I know we're talking about endurance now, and we'll pivot later on. But some people say you can't like maximize fat oxidation, maximal fat oxidation and VO2 max, because there are some mechanistic interference effects. But it might be more like, hey, if you train all out all the time, like really high intensity for big as fuck VO2 max, maybe they're your efficiency, your economy, your fat ox, whatever you want to call it, maybe that suffers, obviously, right? I mean,
so for the first part, I think it's I mean, just if you have two brain cells that you think about, certainly the interesting part is always, I think, this coming up of new sports like functional fitness, where they really do train high volume everything, right? And then you just see, we had a paper where we physiologically profiled CrossFit athletes. I'm talking about games athletes and really high level athletes. And when you look at their critical power, which is, let's say, the maximal sustained power they can do aerobically, it's very mediocre compared to any endurance athlete. Like any half-ass triathlete can push more, right? And I'm talking about games athletes, all right? But this is on the bike. One thing, very important, this is on the bike. There are some athletes are used to the bike, but what would be, I mean, just it's a bit off topic, but still very interesting, I think, to mention. What would be obviously much more interesting is to know their threshold VO2, as well as their power production during functional movements. All right. So, for example, a typical CrossFit workout is Cindy, right? Where you do 20 minutes of body weight exercises. I want to know their power production during a Cindy workout. And this would be, I think, very high. And this is just a specificity of training. That would be one caveat to this. So it doesn't necessarily mean that, for example, functional athletes have a low conditioning. It's just a different conditioning. But it is true that they're not going to be pure endurance or pure strength. The same with weight numbers, right? The weightlifting, I think I saw Gommaar lifting 400 pounds, which is like a squat clean of 400 pounds. It's massive for a CrossFitter, but it's very average for any weightlifter at that age category, age and weight category. So, but that's normal, right? Like it's completely normal, and that is
because he needs to be able to do so many more things. It's insane.
And if we talk about HYROX, for example, I think that would be then we're getting much closer towards elite endurance, let's say numbers, right? Like. I'm talking about thresholds of 17 kilometers an hour, 16 kilometers an hour for women. That would be already, closer, certainly less percentage difference, obviously, because they train much more running. It's useful, it's logical, right? So that's one. To your second point related to interference between, let's say, energy systems, this I cannot really comment on. It's a good point. I never really thought about it. What we do know, obviously, is that if you always train, I mean, there's something in it. If you always train high intensity, for example, like a CrossFitter does, which is obviously also an interesting case study, we do see that on the bike and even on the runner, their VO2 max is not that high. So they always train, let's say, at thresholds. They never do any fat oxidation. They don't have massive mitochondria, likely, because they just have a always high intensity. It does seem to, let's say, interfere with the adaptations to VO2 max. How this is happening? Not that much known about it, but it seems to be the case. Again,
interesting. What levels of VO2 max in relative terms?
Yeah, so
do these elite CrossFitters
really not that high? Really not that high. I'm talking about 55 to 60. Yeah.
Okay. Wow, that's insane.
And
I would have
also,
thought from the top of my head, these have to be the big
70,
engine guys pushing. Yeah. Okay. Wow.
Yeah. Maybe you can put it in the show notes. We have a paper on this where we actually physiologically profiled. We did it strength as well as like endurance parameters in, as I said, high level CrossFit athletes. And I was thinking in the beginning that the machine was broken. They were topping off at like 55, like what's happening? And then it happened again. Again, if we do this is something we didn't really do yet, right? If you profile these guys using a portable VO2 measurement system, for example, during box jumps and squat snatches, maybe we get to higher levels. I think we will get to higher levels, but it has never been tested, so I cannot really comment on this.
Oh, it hasn't been? Okay.
No, it hasn't been. It's crazy. Like,
wow. I mean, there are very well-designed portable devices out there nowadays. Yes. Maybe not as good as lab equipment. Okay, but Jesus Christ. get one of those 6K devices and go out there and do those research.
Oh yeah, this would be highly valuable research, because then during functional movements, first of all, how fast you get up to your threshold level. You think like, I'm doing a couple burpees and a couple of thrusters per minute or per 2 minute time frame. It's easy, but you're getting up to a VO2 immediately of 40, like relatively. Like it's so metabolically active. Like why they have I have some ideas why they have a lower VO2 max. I think it also has to do with muscle mass, obviously, that there's less diffusion of oxygen towards the working muscle fibers. But again, hypothesis driven. I don't know exactly. Could be a good idea for mechanistic studies, that's for sure. But not shown.
What how did you measure the VO2? Like, what was the method of training?
It was just a ramp test. It was just a ramp test on the bike in the laboratory in Basel.
Okay,
on the bike. So that's the thing. It's on the bike. But on the other hand, we had some athletes who trained a lot on the bike for their conditioning, and they were good bikers. Like they also win in the games, for example, CrossFit Games. They win the bike and the endurance event. So they are considered some good athletes, and still they had a VO2 of not 85 for sure. Certainly not. And I found this still to this day striking.
Yeah. Right. Yeah. And I'm wondering about this. Yeah, I also find it striking, because like the textbooks would say, what would they say? Like, okay, let's go back on a bit on the meta level. Usually we read in textbooks, VO2 max is limited by the cardiovascular system, right? The mitochondria can take up way more oxygen than the cardiorespiratory system can deliver. Or am I wrong here? I think they say like the mitochondria
in endurance athletes,
the potential uptake. I thought just in vivo. I thought if we take some random mitochondria ex vivo, like in a petri dish. I mean, and then we put oxygen through it. We see like a 200-fold, 100-fold, I don't know, uptake as compared to what the respiratory system can deliver. So, but then again, we know from observation, and this is, I think, kind of well established, that if you put people in a modality that they're not accustomed to, they won't reach a VO2 max that they would reach in a sport they're accustomed to. So then I think, okay, but I thought the cardiorespiratory system is the limiter, but then again, just switching the modality changes your ability to reach your true VO2 max. So what's going on here? I think you miss. I'm getting confused by these.
Yeah, it's a good point. I think you miss one crucial point, and that is so indeed you have the heart, and you have the red blood cells, right? Like the more red blood cells and the bigger heart you have, likely you will be able to deliver more oxygenated blood within a time frame, let's say a minute, towards your working muscles. But then in the CrossFitters, that's the interesting part, you still need the microvessels to deliver the oxygen toward and to diffuse the oxygen towards the working muscle fibers, all right? And that is known, for example, in weightlifters, that their vascularization, so the amount of microvessels per muscle fiber, is actually pretty low. So then you can have the biggest heart in the world. If you cannot deliver at the muscle level the oxygen, you still will be maybe your mitochondria can take it up, but you still will be reduced. And the second part is, if you have less total amount of mitochondria, it could still be that indeed per mitochondrion you can whatever take up 200-fold of oxygen. But if you only have a limited amount of mitochondria, this could also be a limiting factor. For example, we can actually measure this. So I have now been working quite a bit with a NIRS device, a near infrared spectroscopy device, which
super
is
interesting.
Super
cool
interesting
technology. So cool technology. Right.
So back in my PhD, this was 40,000 euros to buy one, and now it's 700. So that's one of the good parts about technology. And what we see, for example, in myself, I already told you before we started recording, I am rather, let's say, a strength athlete or strength person, certainly not an athlete, that has the opposite. So I have pretty high muscle mass, but my heart volume is not that high. This means that if I start doing hard exercise, also on the bike, I start to deoxygenate my muscles. And you see this very beautifully when I'm looking at 250 watts, you see it goes down. And even though maybe my mitochondria or a mitochondrion can take up more oxygen, it's still, you see it actually in vivo, that the oxygenation of the muscle goes down. So there is some kind of discrepancy.
So even if there wears a lot of oxygen in your blood, whatever, and your heart's pumping through, It's just not getting in the muscle. It's not diffusing into.
It doesn't get into
the bottlenecks.
Yeah. And it is also, it's likely it's difficult to say, or it doesn't get into muscle, or it's not getting extracted sufficiently by the working muscles.
Right.
Because I have more type 2 fibers.
Many points of failure, many bottlenecks, right? Because I hate it when I would take a random old research paper about, for example, VO2 max or whatever, and then they say, this is the one bottleneck, or this is the one bottleneck. Like, usually not, right? Maybe they're like, depending on the type of athlete, depending on the type of circumstances, there might be all kinds of different bottlenecks for all kinds of different persons.
I mean, this is super interesting, right? It's a very interesting topic because you have now... for example, tests, and I'm trying to figure out a test in functional fitness where you do an exercise test to exhaustion. So, for example, 5-minute blocks with 1 minute rest in between, right? And you increase, obviously, the intensity. But what you do, you put also a nurse device on the athlete's leg. And what you can see then is in the resting periods, when the total hemoglobin, so the actual all the blood, so not only the deoxygenated blood, but also of the oxygenated blood, but all the blood doesn't get up to a certain standard anymore, to the baseline standard. When you rest, right, it goes up when you stop when you stop contracting. But when there's always lower highs, it's highly likely that this athlete is delivery limited. So your the delivery towards the working muscle is insufficient. While if you have more of an endurance athlete, he can extract all the oxygen as possible, then you don't see this happening, and then you have more of an utilization limited athlete. So you can actually use nurse to see which type of athlete you are working with, and certainly I would say in functional fitness, it's a bit more interesting because in endurance type athletes, it will always be exactly as you said. The oxygenation stays flat because there's always kind of a balance because the athletes can deliver so much oxygen, right? But once you have a muscular athlete that cannot deliver as much oxygen, you can actually see where the breaking point is and what is limiting his performance. And then, that's much more interesting as a coach than just giving some kind of protocol that you find online and say this might also
be really valuable data. We talked about this in a previous talk, but we said maybe HYROX, and this is a topic for a bit later on. But there are all these ex-CrossFitters or CrossFitters pivoting over to HYROX. But we were speculating maybe it really might be an endurance domain, and it will be the endurance athletes who top all these events. And that might be one cool way of quote unquote proving it, not proving it obviously, but gathering some evidence. Okay, what are these people limited by? What's the reoxygenation looking for those guys and for the endurance guys, and who's performing better? And then we're like, okay, maybe the more endurance kind of profile suits HYROX better. I wanna go back to the CrossFit athletes real quick. How long? I mean, I know that there are so many different types of workouts, and in the actual competition, so many different modalities. But by and large, could you give us an average time of like an average competition time of one segment in a CrossFit
4 to 20
competition?
minutes. 4 to 20 minutes.
20. Okay. So now you mentioned that their VO2, at least as measured on a bicycle, is not that high. Maybe it might be higher in a more specific movement. But then again, what's a specific CrossFit movement? There are so many. But still, they're putting out. I mean, if you could actually measure it in terms of power, and maybe you can talk to us about an experimental device that is out there later, or maybe not. But they can put out crazy power numbers. Their performance is insane. So what's enabling them to go that hard and perform that well if their VO2 isn't that high? So what else is it in their physiological system that's so outstanding for their task?
There are a couple of studies by Manuel Rios actually done in CrossFit where they put on a mask during Fran. Fran is 2159 reps of thrusters and pull-ups, the most CrossFit workout you can possibly find in a textbook. So very high intensity. And there you see, first of all, I don't know the exact numbers, but a significant amount, like 30% of the energy is coming from anaerobic sources. So really way above threshold, pushing in high lactate. This is what you typically see in CrossFitters, like super high lactate. So that's one part of the equation, that they must have an unbelievably well adapted anaerobic system for sure.
Right. And when you say really high lactate numbers, give our endurance audience a little taste of what really high means in your domain.
I did a test on a congress this weekend, and there was a guy who was doing some kind of exercise test to exhaustion, doing CrossFit, so thrusters and so on. And he was standing there, just standing, and he was exhausted, but not completely. And he was clocking at 19.5 millimolars per liter. And he was not even lying on the floor.
Yeah, insane. It's so insane. If you've measured, like swimmers also usually get pretty high, but if you've measured a cyclist or a triathlete for that matter, they'd be dead. They'd be straight up dead.
They cannot get there because their aerobic system is so well equipped that takes away the lactate. So that's one.
Yeah.
I think that's the most important thing, that they are extremely well equipped with anaerobic energy sources because they train this all the time. They do a lot of strength training and they do a lot of power output training. At least I try to program this a lot, where they do whatever sprint interval training, right? Like 45 seconds all out and then 3 minutes off where they have a lot of rest and then they go again, to really push those systems, because it's really important to be strong in CrossFit. Whatever people tell you, if you're not strong, you don't get anywhere. Really, like it's how it is. Certainly in competitions, which is different for HYROX, for example, right? And then they also have the best in the world. They also have a very, very good movement efficiency, and this is completely a black box. So how they do their thrusters, how much forward lean they have, how much oxygen they use to do the same amount of reps in a minute. This is key, right? Like I can do Fran and I can consume whatever 15 liter in 3 minutes of oxygen, but another person who's maybe a little bit less tall than me can only consume 12 liter or whatever, right? So and still he does the same amount of reps and it's still good reps. So there's a lot of stuff that is related to movement efficiency in HYROX, but also in CrossFit and very important the biomechanics. Let's keep it like that. So those
and in
two
this case, it really is a big black box, right? I mean, just as you mentioned. And in cycling, obviously, you have these bike fitting things and biomechanics. And even there, the best of the best tell you, we can do certain types of measurements, and maybe if we profile an athlete throughout all of his career, maybe we can get some insights, but there's really no gold standard way of moving in order to maximize your efficiency. Would you say this is, and it might be even crazier in CrossFit, right? Because the degrees of freedom are just infinite, basically.
It's really like that, and so there's so much more to learn, and it's really just feeling, a lot of feeling and programming, but there's so much, I think, more to learn. That's also to come back to one of your first questions is, you have, as a researcher, you have to also look at opportunities that are interesting, right? Like I could go again in strength training or endurance training, yes, but what about this new thing that is also done by a lot of people? It's not like 5 people do it in the world. No, like millions of people do it, right? So
right. So what's then the quote unquote gold standard to improve movement economy in CrossFit, say? Or is this really just go out there, do the reps, develop a feeling for your body, and just like put in the work and go for the reps?
I mean, for average Joes and Janes, yes, I would say that's it. Learn the movements, because technique, as I said, is extremely important. Learn to do a bar muscle up, learn to do double unders. Like CrossFit is a very, very technical sport. However you want to twist and turn it, that's how it is. Weightlifting, snatching, and so on, get to the mobility, that's one. And then if you are, let's say at the higher end, so an elite athlete, I don't know all the coaches, but there you can really look into, you have apps nowadays where you can kind of look at biomechanics, bar path, and so on. So I would, if I would be, let's say, with my full profession would be a coach of elite CrossFit athletes. Let's say I have a group of elite CrossFit athletes. I would definitely buy a VO2 mask and just let them do certain movements and see which techniques decrease the energy output the most, right? Like for the same reps. This I think there is what you can win as a CrossFit athlete the most.
Unser Angebot für den Retest. Atemgasanalyse, Spirometrie mit dem modernen VO2 Master-Gerät, Leistungsdiagnostik aus dem Labor nur zu euch oder ins Feld, außerdem Laktatanalysen bereits getestet an Weltmeister Alexander Ronchewitsch. Checkt out www.reworkme.art/Leistungsdiagnostik bucht euch euer individuelles Paket und startet in der kommenden Saison, egal ob Triathlon oder eben HYROX, so richtig durch.
Right?
Wonderful, yeah. And it's for them specifically and individually, right? It's not like this kind of way of moving the bar or your body is related to this, but no, for you specifically, this technique versus this one. Yeah, wonderful.
It's like maybe you know the story about Paula Radcliffe, the English runner, world champion.
Please tell the story. Yeah,
I don't know, and she actually there were some case studies on her. So actually, that's one of the things you maybe forgot to mention. There's also some cool case studies in sports science, and actually quite valuable, I think.
Super important. Yeah.
Anyway,
can be super important.
It's like kind of an intervention study, and also observational. Yeah. Anyway, and they tested her VO2 throughout a long period of time, I think a decade or so, and it actually decreased. But her movement efficiency, in some way or another, improved. Maybe because of her tendons, maybe because of her running, and so on. And she was not really known to have the nicest running technique at all, right? So,
and she got faster, yeah.
Yeah, she got faster. She improved her while decreasing her VO2 max. So, so that's why maybe there's some relation there. And in CrossFit and in any sport, but certainly in functional sports, man, it's so important to dial this in because you only have a certain amount of energy and the reps need to be there. That's how it is.
Yeah. In running, I've been completely red-pilled. I think that's what you call it. If you've been the veil has been lifted. Like when it comes to running technique, there are so many studies. Like first of all, there's all these these anatomy guys and biomechanics and this is the way you should move and forces here and there. And then there are like these experimental trials. Like there's no best running technique.
No.
We have world-class marathon runners, virtually the same finishing times with completely different techniques. And we have no clue why. We just know this person has adapted to this style and this person has adapted to a different style. So we need to be individualized when it comes to that.
Yeah, it takes a lot of time. It's not easy. And indeed.
Yeah. So you mentioned these super high lactate levels, and also in the endurance realm, people throw around the term like lactate tolerance. What to you is lactate tolerance? The ability to tolerate lactate? Does it even exist? If so, how do you understand this? And is it a good thing, a bad thing?
Yeah, it's a very good question. It's a bit of a loaded question because lactate is a bit of a tough one. It's a weak binding between lactate and an H+ ion or proton, right?
Yeah.
And so the glycolysis, which is an anaerobic breakdown of glucose, one of the things is coming out there, or the most important, let's say, end product is pyruvate. And when there's no oxygen available, or at this, let's say, no oxygen available, this pyruvate gets broken down into lactate and this H+. And the lactate itself can be used again as fuel, so it's a byproduct of glycolysis, but it doesn't mean that it's an evil product, right? It's actually a good product, but it's the H+ that leads to a decrease in pH of their environment, for example, the muscle, but also the blood. And this is the tolerance you need to develop. And this is also related to your questions on beforehand. That is where CrossFit athletes, 400-meter runners are very good in. You can call it lactate tolerance. It's not entirely wrong, but it's obviously the tolerance against the decrease in pH. That is what you need to, let's say, fight against, right?
Right.
And how you can do that.
Super high lactate levels are just like a byproduct correlated with these super low pH, because the one buffers the other. The lactate buffers the...
Yes, exactly. But it could be that you have, for example, there are some supplements like beta-alanine and sodium bicarbonate that actually buffer this H+. So it could be that your lactate is super high, but the pH of your blood is just marginally going down, 7.0 instead of 7.1, right? And that is what you want to have as a CrossFit athlete, right? You want to be able to generate a lot of power, even also anaerobically, but not decrease your pH too much, because then you will have to puke and you will feel nauseous and feel bad. Yeah. And that is what they train day in, day out in the gym. And that's why they're so good at it. An endurance athlete, he or she is obviously very good and aerobically using the lactate in the type 1 fibers mostly to actually have more fuel, which is perfect for more energy production. So that is a bit. So lactic acid is not really the right term because it's
Right.
We've
done a 1.5 hour long podcast about the new science of lactate. So people, you've been super in depth, and I just want to say people are hopefully prepared for that level of in-depth talk that you're giving them, because we've talked about that a little bit.
Yeah, but it's an important point. Yeah. It's an important point, and people should not be afraid of lactate. Certainly not when they do CrossFit.
Yeah. So I think lactate also is nowadays considered to be this pseudo hormone, right?
Yeah.
It's it can pass through the blood-brain barrier and does some things in the brain. Have there been like any cognitive tests on CrossFit athletes specifically, because they bath in lactate, right? 20 millimole, it's just never heard in triathlon. So that must do something with their psyche.
Yeah, good question.
No? I mean,
you're giving me good ideas to do research, because indeed you can actually do some kind of psychological tests when people are exhausted and so on. Maybe they're better at it. It's actually very important for CrossFit because you need to be very vivid at the end of a workout, see where the rest is, be able to understand the rep scheme and so on. Like when you're really tired, it's not that easy. So I guess they must be good at it. I don't know. Could be very good mechanistic study. I agree.
All right, very, very well. So ketones, real quick, because you mentioned it. You've done some research about ketones.
Yeah.
They have been all the hype a couple years back in cycling, endurance sports, but then people have gotten really disappointed in the actual results, and I'm not sure if anyone's using it as of now, even the pro teams. What's your what's the status quo? Maybe I'm not up to date.
I'm not a full expert, I have to say, so I will keep it quite superficial. I know that when I was doing my PhD, there was a study in cell metabolism, which is one of the highest regarded scientific journals in the world, from an English laboratory, and they found an improvement in rowers when they provided them a ketone ester. So actually, artificially made or synthetically made ketones on top of their carbohydrates. And that's obviously quite interesting, because usually before you had to go in ketogenic diet. That doesn't make any sense to do a rowing competition in a ketogenic diet. Right. But if you can provide them as an extra source of energy that is highly abundant, this could help. And they saw at this cell metabolism paper that they improved their performance as well. And they had a very nice mechanistic study. So, and then, I think it just, the thing is why people kind of went away is because it was not that easy to replicate these findings. I think that's the major thing. We did, not myself, but a colleague of mine in my laboratory did a lot of studies. He probably dedicated his career to this on ketones, and he also found not always like straightforward results. And I also know it's very, very expensive, and it tastes very bad, which are two bad things to put together, I think, for a normal athlete.
In order to market it as well, right? I mean, people have to like using it, and they have to buy it. You have to make a business out of it in the end.
I honestly, as I said, I don't know all the mechanistic details, but I think it's just insufficient in total calories to actually supply energy, that amount of energy for a certain amount of time, right? So that's a bit the whole thing. Like with glycogen, you have around 2,000 kilocalories of energy, and if you just drink one bottle of ketones, why would you all of a sudden be able to push 5,000 calories more on a bike uphill? I find it always a bit strange, because there's always a limitation of capacity. So something to look into. It's still interesting, I think, but kind of hyped away, in my opinion.
Right. Yeah, I think that's also my opinion. At least in the endurance world, what I can say, people have been a bit disillusioned. Regarding performance-enhancing supplements, like legal supplements, is it only the big five? I'm talking about beetroot, bicarb, beta-alanine, caffeine, obviously. The fifth is escaping me for the moment. Carbohydrates, maybe. But is it just those, or is there super promising research on the horizon about?
I would also keep it at those, and also depending on which athlete and which sport, for sure. So actually, my wife did a lot of research in beetroot juice, and she found also at altitude quite interesting results, and also biochemically it makes sense. You always have to think, if you think about an actual supplement, what is the mechanism of action, and how could it actually improve that specific, let's say, pathway or that specific energy system in the athlete. And those 5 that you just explained are really fitting well also from a biochemical and physiological point of view. So it makes sense that they actually improve performance. But some of the other ones, like, I don't know, maybe fish oil, it's probably healthy or it's important. But yeah, do you really have to take it? You can also just eat whatever 2 times per week fish, and there's not much study showing that you actually have to take it, So yeah, it's really confounding and difficult studies to always do on supplements. So yeah, I would also not buy too much into the hype, in my opinion. If you take your creatine, if you take maybe sometimes...
creatine, that's what it was.
Creatine.
Yeah.
Creatine, there's now, I'm not really following it, but creatine, there's a lot of research also that it has positive effects on the brain, right? So that makes it also more interesting. And that is really one that has been studied the most by far, right? Because it really comes down towards energy systems. If you have a higher capacity to break down creatine phosphate and you can do more reps in the gym, it makes complete sense that you will also gain more muscle mass, for example, right? So when it makes sense from first principles, you can always think about it. Yes, that's okay. But when it's like a bit wishy-washy, I would watch out. It's not going to give you all the gains that you need, for sure.
Right. It's super funny, I think, because you mentioned creatine and also earlier like sodium bicarb.
Yeah.
And those are 2 supplements that have not traditionally been used in the endurance world. Not
no,
as
certainly
much.
Not, yeah.
But in the last few years, maybe 5 years, 5 to 10, no, more like the last 5 years or so, both have seen like not widespread, but more and more use in the endurance realm. And I think that's super interesting because like creatine, like well-researched, decades of research, increases strength, likely power output as well, at least short term. And then nowadays, better recovery, better glycogen uptake. And also, many cycling teams are now using sodium bicarb. And triathletes have been starting using it. Have you seen that at all? Or do you think creatine, there's way more to creatine than just power and strength? But maybe recovery, glycogen uptake, blah, blah, blah? Or?
I'm quite skeptical there, to be honest. I haven't seen many really good studies. Maybe it's also because the endurance world is more tapping into the understanding that strength training is important for movement efficiency, and they just use it to improve their strength training adaptations. That could be, I think, a good way to understand it. I don't really see why in an Ironman creatine would help. I don't really see it at all.
Yeah, me neither.
I don't know.
At least not in training. Maybe there is really something to creatine when it comes to recovery of all kinds of tissues. I'm not really sure.
Yeah.
Okay, cool. So let's pivot over to this new super trendy thing that everyone's talking about nowadays, HYROX. Are you personally invested in this new trend sport as a functional sports CrossFit type of guy? And like what's on the horizon for us in this realm?
Yeah, I mean, HYROX obviously took the world by storm. It's because it always, I think it's because it taps into different athletic populations, right? Like that's the key point. They try to make people athletes, right? Like you step into the arena and you become an athlete. That's their goal. And obviously endurance athletes, they're completely used to that. And it's a perfect, let's say, sport for triathletes that are a bit of sick and tired of always doing the same. And they want to do also something else, which I fully understand. And the same for CrossFitters, right? Like I know a lot of CrossFitters who just genetically are better in longer workouts. So they kind of go towards HYROX. It's something new and so on. So that's one. And also online, it helps to have sometimes a little bit of controversy because obviously the CrossFitters just think it is just a CrossFit workout, which is not untrue. But obviously when you make it structured and you make it a sport and you look at it from a different angle, it is something else than CrossFit per se. I mean, everything is CrossFit basically, right? Like a 1RM snatch is also CrossFit.
in one. Yeah, they also do swimming, they also do running, they also
so everything
do cycling.
is CrossFit. But
in
HYROX, I mean, it's a bit more, it is really a long CrossFit workout, but obviously it is different because you have a structured season. You have always the same workout, which is really different than CrossFit. So I do see the differences, and you need a different capacity, you need a different athlete to be good at HYROX. So what I'm looking at, I mean, we are, one of the things we do at World Science is we do a lot of, let's say, practical studies, we call that. So what we do, we ask our followers to do different types of training, mostly in CrossFit and later also in HYROX, where they, for example, do training where they limit the interference effect for 8 weeks, and then they do training where they do everything together, like CrossFit style, and see who performs the best, for example. So these are kind of practical online experimental
Amazing
trials.
approach, by the way. Super cool idea. Like low, quote unquote, low effort, low investment, but just get a good data set. Get some good,
and it's very useful. It's very useful.
In here.
And so the thing, one of the revenue streams of What Science is that also implementing this into training plans, because I think we do have quite some good knowledge on how to train, mostly now for CrossFit functional sports. But we also want to tap into the HYROX realm, because first we have some ideas about CrossFit per se, the movements. And definitely also a lot of people are kind of struggling on how to move from pure endurance sports into HYROX, because it is obviously something different, and that's where we also want to tap in. So that's also interesting for us, obviously, and I think there's a lot of growth and potential. Yeah, it's cool to see that people like sport, like to be active, look up to something. I mean, it's better than sitting in the couch. So we are absolutely happy about this.
Yeah, I think as you mentioned, it took the world by storm. You walk into this arena like a gladiator, but it's way more straightforward and streamlined than CrossFit. So most likely, potentially, it will overtake the popularity of CrossFit because it's so much more approachable, right? It's so much quote unquote simpler. Before we talk about our thoughts, our speculations about the physiological determining factors and the similarities as well as differences between HYROX and CrossFit, you personally, like just you as a person, are you as interested in HYROX as you have been in CrossFit? Or is your heart still more on this more power strength based side of things?
Yeah, I would say the second. So just personally, I like the lifting part. I do think if anything in HYROX, but that's obviously also what they do, there is little upper body pulling, which is just for pure fitness level. Yeah. But that's, on the other hand, it's not their goal. They just want to, I mean, it's the same with triathlon. There's no strength, right? So I don't know. Yeah. Is it the goal to make the most complete fitness test? Certainly not. So, but on the other hand, I also always like the idea of CrossFit to really build like the overall most fit athlete. And I still think they are able to do this to this date. Like, I think CrossFit athletes are extremely fit human beings in the whole way around. So maybe, my heart, I don't know. Yes, I would like to keep training CrossFit per se, but I'm definitely interested in learning a little bit more on the endurance side, like the running and the compromised running of HYROX, 100% also.
Sure, you wouldn't be a researcher and you wouldn't have gotten into academia if it weren't for your like pure interest in furthering knowledge in these domains.
Yeah,
but
you have to pivot sometimes. If you, of course, 100%, I agree. Yeah.
But you personally, you like the idea of just making someone as holistically fit as possible. Like if you take these CrossFit athletes and throw them into a jungle without any kind of equipment versus the marathon runner versus the power lifter, they'd be the most likely to survive, right?
Let's keep it like that. From a physiological, academic point of view, yes, I think it's a super interesting question. Interesting. Is it that relevant for humanity? I don't think so. What is relevant for humanity is that more people get exercising. How? Doesn't matter. Lifting weights, running around, I don't care. And I think people overlook this thing all the time, and they argue on the internet and throwing bad words at each other. It doesn't matter. If you want to do more exercise, that's what is good. And that's why HYROX is good. Simple. But yeah, from an academic point of view, it is super interesting to look at the weightlifters that also can run and vice versa.
Yeah,
absolutely.
It is. So we've talked about this before in another talk. As I mentioned, we think that HYROX is way more endurance than people still tend to think maybe nowadays. So what do we mean by that? Or at least what do you think? Like, why is it way more endurance? Maybe quote unquote, almost purely endurance. And but why are people still so jacked in HYROX? But I think this is going away.
So I tried to go off data, right? And I tested a couple of HYROX athletes, exercise test to exhaustion on the runner, and they have really endurance type lactate curves. I'm talking about elite 15 athletes. I talk about the best in the world, right? So they are very long base, high mitochondrial content, good aerobic base, and not a high peak in lactate. Like a triathlete, maybe a bit less like a triathlete, but close to a triathlete. Then I also tested CrossFit athletes. They have a somewhat similar lactate curve, but the best in the world, I'm talking the elites, but they go up faster and they keep going in this middle zone, 3-4 zone longer. They're better in managing the lactate and so on. And certainly in running, they're not able to run that long, right? So this already just states that if you just empirically observe two different athletes that have been training for 5+ years or 6+ years, almost exclusively in one sport, you are looking at a more endurance type athlete for the HYROX. And then, I mean, it's also just, again, first principles. How long is the race? 90 minutes. What do you have to do? 60 minutes, 90 minutes for average Joes. So let's say 60 minutes, of which 35 or 34 is running. So obviously it's going to be very endurance type. And then the stations, there's only one heavy station or two maybe. That's the sleds. The rest is pure endurance, even for the pro events. I mean, you know better than me. Maybe the wall balls is a bit of a strange one, but yeah, it's not heavy at all, right? So high reps, high repetitions, and long duration of the event is an endurance event. And there you're going to see very high VO2 maxes. It's almost impossible not to have high thresholds and so on. So yeah,
right.
I think
you still see these rather well-built muscular athletes. Do you think this is purely, quote unquote, purely an artifact of ex-CrossFitters pivoting over?
Yep.
And that within the next few years, we'll see these rather slim endurance-y looking guys?
I think so. I think you're bang on. I do think so. You always have to think these kind of sports, they're very new. So, okay, what's the background of the athlete, right? It's not going to be someone who started HYROX doing when they were 12 and then moved up when they were 19 now in the pro division, right? No one. They're all like, I know Ronkovic, he was a teacher. He probably did some other sports.
Swimming. He was a swimmer.
Yeah, he was a swimming, right? So, and that makes complete sense. But you see, I mean, just touching on the topic, I talked also with Mick Jacoby about this. The CrossFitters, like the elite CrossFit athletes, even that have been doing the games and so on, they're not. I don't think any of them, even certainly not on the girls' side, have done a sub 1 hour HYROX. Right? Like even when they specialized 6 months for it, I don't think yet they did it. Makes complete sense. They have a lot of muscle mass. They never used to those kind of movements. It doesn't mean that the CrossFitters are not fit or whatever. They're just not used to this kind of efforts. So yeah, I think it's a kind of a reliquary from CrossFit. And I already said this in one of my videos. I think you if you really want to become better at HYROX, you have to watch out for having too high upper body muscle mass. I really don't think that's necessary. Yeah. And you're going to just carry that weight for nothing.
Yeah, even though it looks so nice. Like we have one athlete and he's coached by my colleague, by Alex personally. And he's just like, yeah, I want this big chest, man. I need this in my life, to paraphrase.
But it's fine if the person is just training for health and fitness, and give him some pull-ups and some push-ups, right?
Sure.
But if you're aiming for Elite 15, I'm just saying something, or the World Championships, it's not going to be push-ups that's going to win the race for sure.
Probably not for sure, right? Yeah, we're just now in the data gathering process of our study that we pitched you last time a little bit. And it will be interesting to see, like will be the first, maybe the second. I've talked to one of the HYROX guys, like the head of their affiliation, not affiliation, but the head of their research team, basically.
Okay.
Like and they are partnered with the university in Manchester, he told me.
Okay, interesting.
And there might be something coming out of their lab, but I think they just tested students and had them do workouts and measured their lactate, and will be hopefully the first ones to actually correlate real race data with max strength and max endurance tests. And maybe we'll have the honor of being featured in one of your future videos.
For sure.
When it's pre-printed or something like that, that'd be cool.
Oh yeah.
And maybe have another talk about this. Yeah. So training-wise, like give us your top of your head. How should, like, doesn't need to be too complex.
No, of course.
How should a template training plan look like for the average guy who's done a little bit of strength training in his life, did some running, and now wants to do a bit of HYROX? Like,
yeah, I think it really depends, and you have to always look at it from two angles. Is the person coming from a more strength background? I would call this CrossFit, or is a person really coming from an endurance background? Right, like those two things you're usually gonna see in some way or another in the HYROX world. Let's say your example, neither of them, they're just some kind of active people. I would put them into the bucket of CrossFitters like this. So I would definitely put a lot of emphasis on running, building up the running volume. That is super important because certainly CrossFitters, they're quite heavy, or strength athletes, they need to go very slow in the beginning and don't overdo it, because in running, it's also shown, it's very injury prone. So you do gonna have a lot of injuries, and you have to watch out with getting too fast on the running. And so if you can already stay injury free for the first 6 months of your HYROX training, that's already good, because you will have to do a lot of running, right? So let's say if you can train 5 times a week, definitely 3 times a week have to be some kind of running. It's early in the beginning, and then 1 time a week maybe strength and high reps back squats. And supersets of sleds, and then maybe 1 time you do a 45-minute workout that is stationary, like having all the stations, and a HYROX specific workout that you see online all the time. But most of the time, I would say you train hybrid, you train running only, really improving your running capacity. That's key. And then everything that is functional, if you're certainly coming from CrossFit, you will be fine. I mean, that's not your problem. It's not going to be heavy at all. Even the pro weights, the sled push is a bit heavy, but for the rest, it's going to be okay. And then the endurance athletes, they have to maintain their endurance capacity depending on how good they were. So maybe 2 times per week running, maybe even 1 time per week, and then go more into the functional movements, learning the difficult ones, meaning the sled for sure, and the wall balls, very important. You can lose a lot of efficiency on the wall balls. So doing like progressive overload on those movements 2 times per week, and then combining this obviously with some strength training, heavier weights. You need to get stronger. You need to have the power to move that sled. So rather lower weights. At
least some minimum baseline of strength that's just required, right?
Yeah, and
but not more than that, whatever it might be. But
and I do think that after some like a 2-3 week build-up period, you want to go relatively heavy even with endurance athletes, meaning you don't want to do 20 rep max on the back squat with endurance. It's not really necessary. They're really, let's say, they don't have a lot of strength and also power in the lower rep ranges, right? The strength to move, the force to move the sled, they really don't have. And that's something you can train with higher weights. Compared
higher weights,
to a
low
CrossFit.
reps, the straight up force that's required, because there's this weight that's out
momentum.
there.
It's pretty, obviously, again, like it depends a bit also on your what you want to do. If you're in the pro division, even the sled, it's really endurance type. Like then you don't even have to do too much strength training. It's all about really endurance. But yeah, I mean, if you want to get a higher up, you need some kind of strength. You need at least 100 kilo back squat and so on, at least. And these things you can obviously train quite well while maintaining your endurance. And maybe last thing I can say is try to train quite hybrid. Try to train not doing whatever 4 times 400 meter runs, right? Like intervals straight into whatever functional, like a heavy strength piece. I mean, it's okay to do it maybe closer to your competition, but try to limit that interference as much as possible, for sure. Right. If you have the time and if you have the possibility.
Okay, right. Yeah, I love it. I mean, we are completely on the same page, and you're obviously so much more experienced than I am. And still, your What you're saying resonates very well. So
Good, yeah.
I like that. So, but one last thing when we talk about this, I love the SIDE principle. Specific adaptation to impose demands. That's like the principle of specificity that the body adapts. It adapts to what you give it, right?
Yeah.
If you do one movement, you adapt to this movement.
Yeah.
Specifically, and maybe there's a little bit of spillover. How strong do you personally think the SIDE principle really is? Because in my world, I love to black box things and just think SIDE. If I want to be specifically better in one thing, hey, maybe I only have 4 hours to train, 5 hours to train, maybe I should do almost exclusively that thing.
Yeah.
And applying this to HYROX, do you think there's a lot of AMRAP, AMOM, CrossFit type workout room for HYROX training, or should for the 5-6 hour athlete should it just be, hey, do these exercises and do it in a race kind of setting?
I think there's too much CrossFit style workouts into HYROX training nowadays. That's what I think. I do think that this principle is very important. But you can do this kind of workout, this AMRAPs and so on, as I said, closer to your race, but including running, I would say. Just cycling in between stations, I don't see that much reasoning for it, except if it's pure strength or you use it as a superset or something. But as a conditioning workout, I would not put too much emphasis on it, because it's not really, it's not CrossFit. You have to accept it. It's not CrossFit. It's something else. And it's, in my opinion, but again, that's my opinion, it's a bit more monotonic, maybe a lot less versatile, the training. It's more structured. It's more like a triathlete. If you want to get better, right? If you really want to get better, and certainly if you come from the CrossFit world, I think it's a different type of training. You really have to run a lot and don't do too many 12-minute AMRAPs anymore. Also relate to that what you just said about. It's maybe interesting about your specificity of training principle. I sometimes think that in CrossFit, it's not necessarily always true. Meaning that basically on the theory of this is, if you always do Metcons, you will get better at Metcons and you will get better at CrossFit. That's kind of the idea, right? Keep workout short and intense and avoid too much volume. But sometimes I think that many of the athletes we see now are kind of limited by this, because it might be a good idea in some times of the season to actually build that aerobic base away from the Metcons. So not very specific training, right? And build that strength away from the Metcons at all, like fully. And then maybe put it together 2 months before a competition. Okay? So, or build a gymnastic capacity where you are able to do 15 ring muscle ups in a row instead of doing 2 ring muscle ups in a workout. All right. And that is something that some people also in CrossFit training miss. It's sometimes good to really train kind of hybrid and then put it together when it's needed.
The age-old question of periodization, diminishing returns, how much base versus how much specificity. Super individual, but room for both. And the optimal training plan has some level of base training and specificity later on, but to what degree you really have to decide for yourself. I totally 100% agree.
Sometimes I'm thinking like as I said, I do CrossFit since then I was 23 or 24. I'm 37 now, and I never did any base training. And for sure, if I would have done base training more like running slow, like even doing CrossFit style workouts slow, I would for sure be better now at CrossFit. I'm 100% sure about this. Right? There is a limit. Like there is a limit to your mitochondria, how much they can respirate, how much energy or oxygen they can use, right? And if you always do these Metcons, there is going to be a limit. And for some elite athletes, that limit is very high, but in some it's not.
Yeah, and just first principles thinking, diminishing returns. If you push a system to its max, like 80-20 rule, the last couple of percentage improvement, you really have to grind, and the volume or the work required increases exponentially, and you might be well advised to invest it somewhere else. It's just how it is in life always, right? Just a principle of the universe, right? Very cool, very cool. I love this talk, Gommaar, so far. Let's close it out with some hopefully rather quick, a bit more personal questions. Okay. At least 50% of your life is academia. Usually what I've gathered is that people both love and hate this world. So what do you love and or hate about academia?
That should be a quick question, you said.
Yeah, sorry. Maybe you can keep it rather. You don't have to keep it super short.
No, I'll keep it short.
In general,
What I don't like about this world, really don't like, is that there's too little tangibility or like feeling with the real world. Like full stop. So professors,
Ivory Tower, right?
like actually Ivory Tower is actually true. Meaning that a lot of research ideas are just coming from the top. They just coming from the professors. They think it's interesting, or think they have a high level of curiosity, and they think it's interesting to look at. But actually, the market doesn't care. Like, it happens a lot. It's not only in sports science; it's in everything. And there's no incentive. There's not real incentive to work together with whatever athletes or the private world, or not enough. Let's say, right? In some labs it's probably better, but in the labs that I have been, so I can only comment on the labs that I've been, it could be improved, right? It could be improved. That's always whatever the idea about public and private sector. But this is a problem because some of the research questions, also in CrossFit, by the way, and also in functional fitness, are just straight up. There's so much waste of opportunity and time here. Like, no one cares about this question. Maybe it's a good study, but the actual thing you want to try to solve is not that good. And you can sometimes better ask athletes, coaches, federations, or work together with them, like what you need to know, and then work together. I mean, there are some PhDs that work like this, which is absolutely good, but not all of them.
But we need more of those. Just talk to each other more. Please, dear researchers, talk to the people in the field and vice versa.
It's always,
and just get along.
Massimo, you know, it's always about incentives. I mean, my professor doesn't really have a lot of, or the professor I work with have a lot of incentive to actually do this, right? Like they have their funding agencies, and it's also always peers. So that's something I do think, very difficult, but it should be improved for sure all around. And that's also why I think also the last couple of years there's a lot of skepticism about academia because of the people sometimes saying things that are not really felt by the people, I think. And
this is what actually runs the world: hidden and not hidden incentive structures.
That's
actually what's driving our world.
So that's one thing that's important. What is good is obviously the freedom of working and be able to think for yourself, learning a lot of new techniques that you can apply in the real world, but you always obviously have to do it. So that's definitely a very good part. And just things, if you have a curious mind, to find new things in the world, like new things that was not known before. Because I actually want to make a post about this, or a video even. Is certainly now with the AI, with everything that is happening in the AI world, the one thing that the AIs, at least at this moment, cannot do is doing the experiments, like actually doing the experiments, right? They can.
They're not embodied yet.
No, they're not embodied. They cannot get the humans together and do they can think about the experiments, and they probably will help you. But actually doing the experiments, that's something that still researchers are absolutely important for. And getting it out in the world and maybe make a video about it and whatever, that is something that AI will probably take over. And also writing even the paper, I think, will be fully automated. But getting the results section, getting the results section of a paper out, like having the actual experimental data, is something that needs to be cherished, and that has to be done by academics as well. And that's something to think about, I think, as a professor, as a laboratory, like how is the world evolving, and how do I manage my PhD students that I have maximal real world output. Hopefully one day it comes together.
Super cool. I love it, man. I'm really smiling right here. Yeah, I'm fascinated by the Eastern mindset, you know, China, Japan, and so forth. And they really also cherish like physical activity. I mean, they have their craftsmanship, and they practice their craft almost for their entire life. These masters doing this one movement over and over. And I just thought about this data gathering process, whatever it might be, and really be in the moment and cherish this physical process of of gathering the data, be it with a petri dish or with a human being, and that should be not just a necessary evil to produce the paper, but a cherished process. And that resonated with me really, really well. Okay, so maybe the last thing now. You're through maybe the first third of your life, hopefully a bit less. Maybe that's about right. But you can become really philosophical here if you want. What's one of the major lessons you've learned that's required for having a good life? Some lessons, some insights, something you personally stumbled upon that you would like to transport into the world. Maybe you don't have room for those kinds of topics in your videos, but maybe something where you think young researchers, young athletes, young interested people out there, they should know this one insight, maybe.
Oh yeah, I'm gonna be It's obviously a deep question, and it's not so easy to answer. But for me personally, it's very easy. It's getting kids. It's getting a family. It's maybe a bit cheesy, but it's
I love
true.
it. I love it.
But I'll tell you why. Like obviously, kids. That's one. I'll tell you why. So what I do see also in my environment, I also work with young, with relatively young women, and you see this a lot, like going for the career and really going for it. And then usually at 30, 31-year-old, like I have a lot of colleagues, obviously there is some thinking like, okay, do I start a family or should I keep working and so on? And I think people should really understand that it's not the end, meaning there's something in your brain that makes you much more efficient once you have kids. So I work now, first of all, in hours more because I just manage my time better. And second, I also work much more efficient and I have 3 kids. All right. So, and 3 small kids, and I don't have parents. Like my parents are not here in Switzerland. So I have obviously a good wife, but she also works. So this is one thing that I maybe could give to people who are thinking about, should I go for a career or whatever? Am I ready for a kid, for a child? I would 100% say you're never ready, but if you even think about it, try to do it at least, and your career will not necessarily suffer, even not when you're a woman. Obviously, for the men is slightly easier, unfortunately. But for the men, for the woman, it doesn't need to be that. You can be still very efficient, take care of your kids, love your kids, and still be able to have a great career and just have a nice job and doing fun stuff in life. It's not the end, certainly not. So that's something I would hope to give, because I see more and more people struggling with this question, right? Like, should I start or whatever? I would say, really try to start, and it won't negatively affect you for sure.
And with these words of wisdom, thank you so much, ladies and gentlemen. Gommaar D'Hulst, thank you for being on the ReWork podcast.
Yeah. Thank you for having me. Until next one.